So today what we're going to do is we're going to be practicing these logarithm identities and the inverse properties of logarithms to kind of help us evaluate and simplify equations and find solutions. Okay, so yesterday we talked about what a log is and what a log means. So we're going to use kind of that definition or changing it to its exponential form in order to solve some of these. So for instance, this first one, where it says evaluate. If we're just looking at this part right here, so this is going to be 2 times whatever this log base 4 of 64. Now remember, reading a log, this is basically saying the base, whatever number's in the base, to what power gives me the number that's sitting right here. So to 4 to what power gives me 64? Well, that's 3. Or you could think of it as this way, if we rewrote it, log base 4 of 64 equals y, and change it to its exponential form, it's 4 to the y equals 64, which is basically what we just said. And of course, 4 cubed is 64. So the same thing with the second one. 3 to what power gives me 1 over 27? Well, 3 cubed gives me 27, and since it's 1 over 27, the reciprocal has been taken, so 3 to the negative 3 power is 1 over 27. So this whole thing is negative 3. So 2 times 3, which is 6, plus 2 times negative 3 is negative 6, which means this is 0. So this is equal to 0. Okay, so we're just using our log identities and our log properties to kind of simplify these to find our answers. Okay, so the same thing here. So this is really 2 times whatever this is. Well, again, 12 to what power gives me 144? Well, 12 squared is 144. Plus 12 times, and what is this? 36 to what power gives me 6? Well, the square root of 36 is 6. So the square root is the 1/2 power. And 2 times 2 is 4, plus 12 times 1/2, which is 6, which means this is 10. Okay, so we're just using these log properties to simplify things, okay, and evaluate them. All right, so now we're going to do the same kind of thing, but we're going to use it to solve this. We're going to solve for x. Solving for x just basically means getting x by itself, isolating it. Okay, so this is the part that I get it by itself. So first step is subtracting 2. So I get log of negative x equals 2. And again, this is one of those times where I can change it to its exponential form. And remember, if there's no number, that's base 10. So this is 10 to the second power equals negative x. So changing it to its exponential form, 10 squared equals negative x. 10 squared is 100, and we're going to divide both sides by negative 1, so x equals negative 100. Okay, easy, just basic solutions. Okay, same thing here. This one we don't have to do any simplification first, we can just change it to its exponential form. So 8 to the second power equals 8x squared. So 8 squared equals 8x squared. Okay, so 64 equals 8x squared, getting x by itself, so we divide by 8, divide by 8. So 8 equals x squared, which means you take the square root of both sides and you get x equals plus or minus the square root of 8. And most common mistake is forgetting that plus or minus part. Okay. All right, this last part. Now we're going to be using multiple identities, okay, and properties. So this first part, this is the identity that says if you take the exponential with a log plugged in like this, you get x. So for this one, since the base is the same, I'm left with x squared. Plus, this is an identity. This is the identity that ln, or natural log of e, is 1. So I'm just using that one. That's this, ln e equals 1. So that's this. Then this one here, this last one, is the other inverse property that says if I have something like this, log base a to a to the x is x. So for the bases match, which means I'm left with 2x. So we get x squared, move the 2x over. So x squared minus 2x plus 1 equals 0. And this factors, so x and x, what are the factors of 1? 1 and 1. Positive, this is negative, so this is negative 1, negative 1, which means my solution is x equals 1. Now we'll talk about this a little more later, but there's certain numbers, sometimes we get solutions that are not actually solutions. And we'll talk more about that when we talk about the graphs and what the functions look like. But that's basically it.